right, good morning. Did you enjoy the keynote? Awesome, yeah, pretty awesome stuff there. So, hello, welcome to Build. Welcome to the first breakout session for today. 6 reasons to move your C++ code to Visual Studio 2015. I am Marian Luparo, and I'm the program manager lead for the Visual C++ team. And today I have here with me Ankit Asthana, the senior PM lead on the C++ team, and Andrew Hall, PM lead on the Visual Studio debugger team. And we're very thrilled to have you today. Can I get a show of hands how many of you have tried Visual Studio 2015 to date for C++ development? Oh, it's a good fair share, more than half. And how many of you are actively using 2015 today for your development? A bit less. OK, so while this talk is designed to to talk about the value of 2015 for people that are coming from an older version or other C++ tools, for everyone here, you'll have something useful to learn today. We are going to be talking about the RTM release, Update 1, and Update 2 release that just came out today. So there's going to be plenty of new features, and we have a few announcements as well. Hopefully, going to keep things interesting. Now, the 6 reasons could really be talks on their own. So we're going to try to keep a fast pace. We're going to do demos. We're going to throw a lot of content over your way. We'll try to keep questions at the end. And of course, if you have a yes/no question, by all means, raise your hand, and we're going to try to answer it and move on really quick. All right, so it's going to also be a countdown. So we're going to start with reason number 6. And for that, I'm going to invite Ankit on stage. He can tell us more about it.
Right. Can you guys hear me? So is there a clicker?
No clicker.
Oh, OK.
Spacebar will be a clicker.
All right. So the first reason that we're going to talk about here is really, how can you guys actually benefit from day one when you move to your Visual Studio 2015 experience? So how many guys here have had trouble being able to update compiler tool sets as you upgrade? I was actually expecting a lot more than that, but that's good. So what happens is, as you move to 2015, we usually tie it with a new compiler tool set as well. And sometimes that might take time because of breaking changes or conformance reasons and so on. So what you can still do is that from the very day one, you can actually still use the IDE features, language service features like IntelliSense and so on, without upgrading your tool set. And how do you do that? Well, that's what that picture talks about there. So this is really, your day one experience. You install Visual Studio 2015, and then you start using the IDE experience without upgrading the compiler. Now, when you are actually, looking into upgrading your, tool set, what you'll notice in 2015 is that it will actually build faster. And the reason why that's the case is because we realized from user voice and talking to you guys that a lot of times the performance of our tools is not that great. So that's really what we've tried to improve in this particular release. And when you take a look at build throughput, it's really 2 scenarios. The first scenario is really about clean build, or when you actually, you get your sources from your repository and you start building, or you do a nightly build if you have a build system set up that builds your product nightly. And here in this scenario, compiler is kind of like takes the lion's share in terms of build time. And the other experience is really your edit, build, debug cycle, which is when you make an edit to your source code, a couple of source code files, and then you build. And that's really where linker comes into play. Link time becomes the majority of your build time there. So what you'll find with 2015 is that we've kind of worked on improving both these scenarios. So first of all, the linker should be on average about 2 to 3x faster for non-whole program optimization builds. So that's just out of the box, you should see that. If you guys are not seeing that, you guys should talk to us. The other thing you guys will see is that incremental linking, which is basically a feature that we've had for years, we've done a lot of work in improving it. We've also added a bunch of new scenarios to it, which make incremental linking happen a lot more often, again, improving your link time. So here are just some examples here that I can show you. I don't have a laser here, so I can point to it. The first thing you're seeing on the left here is basically Connect Sports Rival. If you go to your neighborhood GameSpot shop, you can buy this game there. It's an Xbox One title. It used to link in about 680 seconds. it links in about 68 seconds with Visual Studio 2015. The higher bar on the left in that chart is Visual Studio 2013. The lower bar, the dark blue bar, is really 2015. Another one that I want to call out here, I don't know how many people are gamers here or first-person shooters, but Destiny is a very popular game. And that used to basically build with 2013 in 84 seconds, and with 2015 it builds in 8 seconds. And the last one I'll call out here, if you've never heard of any of these products on the left, I'm sure you've heard of Chrome. And Chrome is also a benchmark that you can download on your laptops and build it yourself to see what we're talking about here. You will still see a lot of link time improvements there, as you can see from the chart, with 2015 again. So what's some of the features that are driving this, right? Like, why are you guys seeing, why should you guys see some performance benefits here? The first feature that I'm going to talk about is /debug fastlink. What this feature is really is a linker flag, but a little bit more than a linker flag. What it really does is that it creates a new style of debugging PDB. And what this will do is it basically allows the linker to do a less expensive job in the creation of the PDB itself, but it actually provides you much faster link time. And again, you don't have to worry about the debugging experience. The debugging experience roughly remains the same with the Visual Studio IDE. So that's the first feature that we have that's resulting in this gain. Another feature that I want to talk about here in that list is really incremental linking for static libraries. So if you look at the structure of games especially, the way they're structured is that there's a lot of static libraries, and then they kind of like get consumed to build a final PE or EXE or DLL. And what was happening before is that if you're actually working and making changes to the static libraries, they actually won't get absorbed as a part of the incremental linking process. Now, well, with this release, we support incremental linking for changes that you make in static libraries as well. So that's the first set here. So how many guys actually tried out the new linker and thought that was fast? Does anybody in the room thought that? Oh, Dory. Thanks. Another thing here. So this is another feature that we've added. How many guys here know about LTCG or whole program optimization? A couple of people in the room. Really. So this is really our extreme optimization setting. What this does is that it allows us to do whole program optimization, which really means is that we can do inter-procedural optimizations. So for example, we can do inlining across source files. We can do inter-procedural register allocation, range propagation. And what that really gives you is single-digit gains in terms of CPU performance. A lot of gamers, a lot of enterprise companies use this performance setting to be able to build their applications. The problem with LTCG today, though, is that it actually also increases your build time by a huge factor. So it's going to be like twice or 3x the time it takes to build a regular non-WPO optimized build. And with this feature, what we're really doing is we're actually making this process incremental as well. So now, not only can you benefit from the performance that LTCG provides, but you'll get the same kind of build time that you expect with a non-whole program optimized build. So it's really about you being able to choose both the goodies here, performance and productivity, from your build time experience. The switch here is LTCG incremental. And this picture here that you're seeing is really our own compiler building with this feature. The red bar there is basically the existing LTCG feature. And the dots that you see there are really check-ins from our developers, and it's being built by incremental LTCG. You'll see a 3x gain there with this kind of an experience. So you guys should really try that one out. Something else that I want to get into as well is, the 2015, something that we're also doing is we're partnering with Incredible. So how many guys have actually maybe heard about Incredible? Come on, give me a show of hands. See, there we go. So Incredible is obviously, people already know about it. It's a software acceleration technology. It lets you build your, not only just your sources, but other stuff as well across a network of machines. And you can really build it fast as a result of that. So starting with 2015, with the partnership that we have with Incredible, you can now download Incredible from within Visual Studio. And out of the box, what you'll see is that if you're using the Incredible solution, it actually generates a much better build plan than MS Build, which really results in some build time improvements. Likewise, it also has a great visualization tools. So if you're actually building and you want to see where the bottleneck is, how your usage is for your CPU, your I/O, your disk, you can really use a graphing tool to be able to understand that. And out of the box, when we benchmarked it, we roughly saw about 10% improvement on our laptops and devices. And again, so the picture here is really about the ACE benchmark. It's a C++ benchmark. Without Incredible, with Visual Studio 2015, it builds in about 6 minutes, 32 seconds. With these features here, which you get out of the box when you download Incredible from within Visual Studio, you'll see a 10% improvement. And then if you use the paid features of Incredible to be able to set up your cluster for machines and nodes to build your application, you'll see 10x or 12x gains depending upon how many nodes you have in the cluster and so on. So you guys should really try this out. It's really easy to do so. You can look in the File New Build Accelerator menu. This is a new entry item that we've added. Once you click there, you'll see a link to install Incredible from within Visual Studio. Once you do that, you'll be able to benefit from all these features. So next, I want to get into, so I talked about a build time a little bit. I want to talk about not only that, when you're building your app now with 2015, not only is it going to build faster, but it's also going to run faster. And the reason why it's going to run faster is because we've done a lot of work in being able to add to our existing optimizations, make them happen in a lot more scenarios. So the first example that I have here, that I've pulled out here, is really vectorization of control flow. So if you take a look at this piece of code, if you notice, this is a loop, and inside this loop, there's an if condition. And if conditions and control flow is really bad for optimizers because it makes it harder for us to do things like vectorization and other optimizations. So in this particular case, the optimizer is smart enough to be able to convert that if case into more of a conditional flow in a different way that allows the vectorization to still happen. So that's just one example there. Another one that I want to talk about here is loop if on switching. And what this one's about really is the fact that inside your loop, again, you might have control flow, but this control flow, the if logic in there, is actually not changing in the loop. So what you can really do is you can actually host the if condition outside the for loop, and then what that does is it actually makes it really simple for the vectorizer or other optimization to play now, because the loop is actually more parallelizable. So these are just a couple of examples how you can use this, and so on. There's also a bunch of other work that we've done that you can read into. And with that, I'll get into the last section that I want to talk about here, which is, again, benefits that you got from day one, which is about security. So not only is your code going to build faster and run faster, it's also going to be more secure. So we really have two features here. The first one is /godcf. And what this really does is it protects your instruction stream. What it does is it's able to analyze your control flow for all indirect targets and so on, and making your code more secure. I'm not really going to talk about it much here, but you can read about it and click the link that's there on the slide deck. Likewise, guard is at a software level and more for instruction set. More at guard is at a compiler level, but there's also another way to be able to protect make your code more secure using Intel MPX or memory protection extensions. And again, this is a new stuff that we've done in 2015. You can currently go try it out by adding the experimental flag D2MPX in the C++ command line. And again, when you build with this, your code is going to be more secure. So again, I think that's pretty much it to wrap it up for the first reason, Marion. I'll give it back to you.
So basically, you had no code changes. You just moved to 2015. You recompile your code, and you throw in some more switches. You get better build throughput, both for debug and optimized builds,
right.
Faster code at runtime, and potentially more secure if you want to turn on guard.
That's right, yeah.
And MPX. Awesome.
Cool.
Thank you. I bet people want to see some code changes too, right? Now that we're inside Visual Studio 2015, let's talk about productivity. There's been a lot of improvement in 2015. We worked very hard to make sure that we bring in new refactoring capabilities, as well as code generation and quick fixes. And we also made several improvements to the IntelliSense database engine. So let me switch to a demo really quick. All right, so what I have here is a very successful game in the making. Don't hold us to a very high bar yet because it's still in prototype phase, but us three were very confident that we're going to make it high. It's a guess what game, so basically there's a server side that picks a number, and the clients connect with it through REST APIs to guess the number, and whoever gets the fastest guess wins. So let's see, I have the server running over here. This is done with C++ REST APIs, which is one of our cross-platform libraries for building web services and connecting to web services. So I just do Control F5. It's between 1 and 100, so let's go really quick on this one. Oh, yes, I got it. So it tells my name, and it tells me that I get 5 guesses in 10 seconds. Now, what I want to do for testing purposes, obviously, I like to automate this guessing exercise. So I'll just go in the code, and I have it right here. This is the game loop, and I have this 2 lines that actually asks for the input from the console. Yeah, I told you not to hold us to a high bar on the UI yet. What I want to show you is control dot. actually has new capabilities showing up. This is the light bulb functionality. So if I go to Tools Options really quick, and I search for experimental, we have several new functionalities open up here, and one of them is extract functions. So I'll turn it on really quick, and now I can go back, select this control dot, extract function. What extract function will be able to tell is all the variables that are being used, and it will offer to create a new function for me, basically hoisting the code out of the current location. So let's say I name it compute guess. And there you go. It got created over here. It's probably at the bottom. And now I will start working on, let's still output it really quick. All right, so we'll work on just doing a guess here. I really need this method to be part of the game class because the game class stores some state in it. So I'll just do this. Obviously, this is going to squiggle because I have the definition, but I don't have the declaration. So again, I'm going to press Control dot. And the IDE will be able to tell that there's no declaration for this function. And with one click, I will just create it. It gets added into the class body at the right location in the order of the functions are defined. And right now, the squiggle should just go away. So let's see, really quick results. If it's too high, then I have a vector. I think it's called ranges. I'll basically update the range with a number to not go as high. Oh. So bear with me for a second here. Now I'm going to pick a new number, and I'm going to pick the average, but rather than just adding them, I'll use this function, which is accumulate. It adds all the elements in the vector, and then I'll divide it by ranges size. So as you can see, still accumulates squiggles now. What I would do, I would normally hit F1 and go to MSDN, but I have you all here. So does any of you know in which header this method is being defined in the standard? Any guesses? Algorithm, I heard once. Any other guesses? We'll try algorithm. Let's see if you're right. Visual Studio will actually suggest that it's in numeric. So this is a new functionality. It's an experimental extension that you can download from VS Gallery, and it will suggest pound include headers for you from the standard library from any types that you're using as part of your solution. So this will make it much easier to code as you start using stuff. It added the pound include at the top, and you're ready to go. All right, so we are pretty much set to go. One thing that bothers me is the name of this variable, which is probably me. I named it like this, but this gives me the opportunity to show you rename refactoring, which is probably one of the refactorings that you're going to use most often. So I can say guess valid range instead, make it more explicit about what it does. And I can pick to do the refactoring directly, but I do want to review the changes before I do. And I can pick the scope of the refactoring. Current project is fine for this demo, but entire solution sometimes makes sense. So preview actually gives me a good preview of all the locations that were identified, including the ones that I just added. So I can hit apply, and the changes are done. All right, so one last thing before we see this running. So another refactoring we have is move definition location. So if you prefer the code to show up in the header, in the class definition, I just select this, and you can see that it just got inlined. This works both ways, so I can go back and add it here. I don't need it to be inlined, but that's how it works. So let's see if this works and actually guesses the number. Hopefully I didn't do any bugs, right? Okay, so that was quick. Unfortunately, the server can tell that I'm a bot. I'm not a game player, so it's not my name. That's not my name. But bots are really popular this day, as we can see in the keynote. So it's not a bad thing. But one thing that I want to do really quick is show you C++11 features. Just we're going to do std, this thread. We're going to delay a bit the results such that we can actually trick the server into thinking that it's a person doing the typing. So here, I would normally do chrono of seconds, of 5 seconds, let's say how much I want to wait. But instead of this, I'll just do using namespace chrono literals, which are new literals being defined in the standard for different metrics. So here I can say 0.3 seconds. And this is what actually you think it is. It's user-defined literals that allows us to define types. And I can hit go to definition. Inside ID, it takes me to the definition of this operator, which is declared like that with an S. And then it takes a double, and it creates a strongly typed object. Now let's see if this is going to be enough. I should have not used so many templates. So this was slower, but I'm still labeled as a bot. So let's add some more. Being a strongly typed object, I can actually do operations on it. So I'll add another 300 milliseconds, but let's go with 3,000 microseconds, because I also want to show you a very simple C++14 feature, which is the digit separator, which doesn't do anything, basically, but it's just for readability. Definitely want to use that one. Oh, where'd you go? OK, yes, I'm back to being called Marian. So that was the demo. I showed you refactoring operations. In addition to rename, symbol, extract function, and move definition declaration, we have convert to raw string literals, which is what it says it is. If you find a string inside your code base that uses escape sequences and is unreadable, just right-click on it or do control dot and choose convert to source string literal, and you're going to get this nice view on the right-hand side. Code generation, you saw create definition and declaration was basically when I was missing the declaration, I could create it all of a sudden. I can also do it the other way around. I can write a class definition. I can add 20 declarations of methods, then right-click on all of them and say add definitions for all these functions for me in the C++ file. Quick fixes, I also mentioned the suggest missing include. I showed you that extension that is on VS Gallery comes also with a fully qualified name disambiguator. So if I would have written just accumulate, it would have suggested to disambiguate to std accumulate, or offered to do using namespace std in front of the accumulate call. Also, I mentioned IntelliSense, improvements in the engine. We changed the way we do template deduction in IntelliSense, which is different than we do it in the compiler, just for the purposes of making it more readable. So we use some heuristics to actually simplify, and you can see all of our tooltips are now much shorter and actually tell you what you're actually coding against. It's a W string, not a basic string, and so on. Single file browsing in IntelliSense means that you can just open a file in the editor and you can start getting IntelliSense immediately. You don't need a MS Build project. You don't need anything to configure it. There may be additional include paths that you may be set up, but we have the right reasonable defaults to get you started with STL and so on. And an important thing, there is a new database engine that is an advanced tab starting with update 2. I do recommend that you should all turn it on. It's still a switch, but we heard very good feedback from some of our largest ISVs that have been trying it, up to 2x improvements in the database population at the beginning. And also, this comes with better cancelability of operations, and it'll actually help you be more productive. All right, so that pretty much summarizes the editor productivity features. For the next topic, I will invite on stage Andrew Hall, which is the PM lead for the debugger team. So I wonder what he's going to be talking about.
Thanks, Mary. So I know nobody here has ever written a bug before, but just on the off chance that you might, let's go ahead and take a quick look at what some of the new features we added into the Visual Studio Debugger have been. All right, so I have Marian's application here. I'm going to go ahead and just click it and launch it. And I'm back to the manual mode, and I'm working on different forks, so we can go ahead and deal with all our merge conflicts later. But notice the first thing that happens when I enter, I've added some logic to try to give the user a good error message when something's misentered. And it's telling me the input must be an integer, but I entered 0. So what's going on here? So if I go to the output window, I can see that an exception's being thrown. So instead of hunting around in my code, what I'm going to do is I'm going to go debug windows. And and then I'm going to choose the new exception settings window. If you've ever used this before, you're going to notice that it now opens instantly. No more waiting for it to open. And it has really fast modern search. So I'm just going to search for std exception. And when I do that, I'm going to go ahead and just try to run my application again. And when I hit enter, the debugger is going to go ahead and just break on that exception. So I'm now breaking on any exceptions as they're thrown in my code. So when I click break here, I'm going to actually stop briefly and point out that I'm actually running my application as x64. So if I go to the processes window, wherever that happens to be, I will prove to you that I'm telling the truth. And that in this particular case, oh, it doesn't tell me, but anyways, just trust me. It's an x64 application. And so if I look, I can see that the issue that I did here was I made a logic error that I'm not accounting for the fact that when I get the strings, that the characters, that it's going to be a null terminated string. So I'm just going to go ahead and use one of our favorite features in Visual Studio. It's called Edit and Continue. It allows me to edit my code while in the process of debugging. I don't have to stop. And I'm going to say if nums of x equals null, then I'm going to go ahead and break. So I'm just going to terminate this loop. I'm going to click Start here. Oh, I clicked Stop Debugging. Sorry about that. I'll come back and show Edit and Continue works a little bit later. But I want to say that we've added Edit and Continue now for debugging of x64 applications in Visual Studio. So that was one of our things that we had never supported before. We had Edit and Continue up into Visual Studio 2010. And once we rolled forward to Visual Studio 2012, to enable it, we would fall back to the Visual Studio 2010 debug engine, which would mean that you'd lose a lot of great features like NatViz that people really like for dealing with visualizing the results of variables of native types. So by introducing x64 Edit and Continue, we've also brought it to x86. So now you have Edit and Continue enabled by default whenever you're debugging your C++ code inside Visual Studio 2015. We made a lot of additional fixes in Update 1, so I'd recommend rolling forward to the Update 1. So for example, the feature that Ankit talked about earlier, FastLink, Edit and Continue, you need Update 1 for that to work with the FastLink feature. But, so I mentioned NatViz briefly. How many people here have ever used NatViz before in their code? Okay, just a couple handfuls. So it's a really cool way to visualize your native types. So I'm going to hit this breakpoint. And I can see that this guess result is, I'm going to go ahead and add it to the watch just to make it a little bit more visible. But it's not a very nice looking display here for me as a user. And when I expand it, I can see that I have this guess, and then I have the server result type, and then it's the result, and then I have this m_binary data. And what I really care about as users, all I actually care about, I want to know what my guess was, and I want to know what my result was. So if you dealt with NatViz before, you'd have to go edit a file under the Program Files Visual Studio installation directory. In Visual Studio 2015, I'm not going to really talk about exactly what NatViz is, but it's an XML way of telling the debugger how to display your variable to yourself. And so in this particular case, or type. So I'm going to go ahead and just uncomment this here. And the other thing that we've added in Visual Studio 2015 is now as soon as I save this, you're going to see the watch window update here. So if you're trying to get your NatVizes right, the debugger picks up changes instantly. And I think I also mentioned, but my NatViz file is just a member of my project. It's just in the top level of my project directory. So no more hand editing, or no more editing files down in program files, and then having to restart the debug session to see those changes take effect, and when you get them right. So I'm going to go ahead and leave that now that we have that done. And I'm going to go ahead and continue running here. And so I need to unset my breakpoint. I'm actually not trying to get it right. But one of my complaints is I actually think that my results are coming back a little bit too slow. It feels a little bit sluggish. Marion's was much, much faster than that. And notice over here in the debugger, we have something we call a perf tip. And what the perf tip is doing is it's showing me how long that code took to execute under the debugger. So this works for stepping. I'm using a feature called set next statement, so I can grab the little yellow arrow and drag it up and down. I can change where my code's executing. I don't have to run back. And as I step in, I can see that it took less than or equal to 1 millisecond to step into the guess number. We don't have a fidelity below milliseconds just because this is a approximation. So if you see 1 millisecond versus 2 milliseconds, don't key too much up on that. But if you see 1 millisecond versus 20 milliseconds, you can tell that something's going on there. And these are definitely more accurate on Windows 10. Just a quick plug for Windows 10. We added some instrumentation into the operating system that helps us get them even more accurate. So if I were to, for example, have stepped into this guess number on Windows 8.1, it probably would have said it was about 5 milliseconds. And that has to do with the fact that we have to wait for a context switch to occur. Where in Windows 10, we know exactly when that step completes before the debugger gets context switched back in. So in this particular case, I'm going to go ahead and step. And I can see 1 millisecond. I should also mention really quickly that they work between breakpoints as well. It's not just stepping. So if I want to run to the end of this function and see how long that takes, I can see that it took 750 milliseconds to do this whole thing. You had to slow yours down to 600 milliseconds to not be called a bot. So obviously I have something going on here that's really, really slow. So I'm going to come back around. And so I'm going to go ahead and step here. And as I step, I can see that this build query base it seems where most of my time's going. It was like 760 milliseconds, and this is 715 milliseconds. So what's going on? If I click this, it's going to open a tool that we call the tool window that we call the diagnostic tools window. Let me unpin this.
So you click the perf tip.
I clicked the perf tip exactly, and it opened the diagnostic tools window. And it's showing me a couple things. So I have an events tab. This shows me all the times that I've entered break state. I can see the time that I entered break state here, and I can see the duration. So this is giving me a full history of those perf tips that I had. So if I want to, as I'm stepping through code, as I'm hitting breakpoints, if I want to understand, hey, what was that number that I just saw on my last step? I actually have the history here. And there's a timeline up here that it's being filtered. So I can zoom out, and I can see that things are being filtered. So I've hit a break multiple times. But the other thing I want to talk about here is in terms of figuring out what's going on here is I want to go to my CPU usage tab. And so we have a CPU profiler now integrated into the debugger as well. And so in the debugger, I can see as I go down that I'm spending about 99% of my CPU in this guess number thing. And that 99.58 of that is being spent in this build query base. And it's just doing string operations. So I'm doing a bunch of string concatenation to build the query that we're going to send across. But I don't need to do that every time because I can see I'm actually appending my guess here. So that's going to be the same every time. So I'm going to take advantage of edit and continue here. And I've already added a member variable that's called query base. And so as I do that, I'm just going to go ahead and bring my instruction pointer back up. And edit and continue is going to kick off. It's going to recompile that code for me.
And it'll just continue going after that.
And it should just continue going after that, exactly. Wow. But we're not going to call the function. We're just going to leverage the fact that we paid the cost once. It's a member variable, and everything should work great. All right, so once that finishes, let's go ahead and hit F10. Let's step again, and I can see that it took less than or equal to 1 millisecond. So now when I run here, perfect, less than or equal to 30 milliseconds to do all of that processing now, including the call to the server and getting the result back.
Well done.
So using perf tips and the integrated debugging tool, I'm able to go ahead and fix that issue. The last thing, as I zoom out, that I think I've noticed as I've been going is it looks like our memory's been upticking the whole time that we've been debugging here, Marion.
Oh, that's right.
And so I use edit and continue. We've been doing some stuff. So I'm going to just go ahead and restart the debug session. But what I'm going to do before I do that is I'm going to turn on the integrated memory tooling that we've added into the debugger as well in Visual Studio 2015. You have to opt into this because it is going to introduce a performance overhead on the debuggy, about 20%, because we have to track every allocation and deallocation. So it's something that's a really powerful tool if you're diagnosing a memory leak, but you don't just want to leave it running on all the time. So I mentioned I've used edit and continue. I just want to start from a clean state to make sure that my memory, everything's good with my memory.
But you could turn it on during a debugging session.
Yeah, you could just turn it on and keep going, exactly. The only reason I'm not is I want to be in a clean state. Yep, I just want to be in a clean state. I drag the instruction pointer around. Who knows how many normal code paths I changed and didn't hit. So I'm going to go ahead and take snapshot. And what this is going to do is this is going to set a baseline. So it knows everything that's been allocated up to this point. And let's go ahead and just make a couple guesses. Hopefully you don't guess the right number. Oh yeah, let's unset our breakpoint right here. And I can take snapshots either while the application's just running, or I can actually take a snapshot at a breakpoint as well. So if I go back in here and hit 0, and taking a snapshot at a breakpoint gives me one small advantage that I'll talk about here in a minute. But now I can see between my two snapshots, I've allocated 66 extra objects in that time for a total of about 2 megabytes. So when I click on this, it's going to open another window for me, and I'll go ahead and just open this up to full screen real quick. And so what this is showing me is all the types that have been allocated since I took my first snapshot. So up here I have the compare to, and I have a baseline, so I can take as many snapshots as I want. At the moment I only have 2, but I could say none, and when I do that, it does the math for me, and it tells me the things that I've been allocating. So I can see that most of my memory is going to this G result type that I have. And when I click on this little icon here, it brings me into the instances view, so I can see the extra instances that I have since my previous one. I can see the stack where that was allocated in my application. So it's inside this Lambda operator function. And if that doesn't mean a lot to me, it does have the source line number. But the other benefit of being stopped in the debugger is I can actually just inspect the object under the debugger to understand exactly what that object is. So in this case, I can see that my guess was 0, so that might mean something to me as well. That's the one advantage of being stopped at a breakpoint gives me over just taking snapshots.
You get all the data
running.
tips.
Exactly. If the application's running, we won't try to inspect the memory because we aren't confident whether it exists or not. And so I can right-click, and I can say go to source code, and it'll take me into my application where that object was allocated. So I can see what's happening is I'm allocating this guess result, and then I'm passing the pointer back up the stack. So I'm going to go ahead and just unset this breakpoint and go ahead and step out of this function. Oh, well, hold on. Let's just go ahead up to my call stack. All right, that's all right. So let's just come back here into my guess loop. Let's set the breakpoint here. Let's run back up here. And so I can see, yep, sure enough, I'm allocating the memory. I'm getting it back, but I'm never actually freeing that memory.
That's right.
So let's go ahead in here and let's free that memory. So let's say delete guess result, and then let's go ahead and set guess result to null. And so again, I'm just going to restart here just to kind of give myself the confidence if I don't see any new allocations that I've tweaked that. So it's going to rebuild that application. And then now let's take a snapshot. Let's make a couple guesses. 0, 0, 0. And then if I take another snapshot, there's a few things that have been allocated, but it looks to be a lot less. So if I go in here, I can actually see that guess result is not leaking anymore. So I might have some other problems in the application that I want to look into. But in this particular case, I can see that I fixed that particular memory leak.
It's definitely not my bugs that I entered.
It's not my bug anymore. So using the integrated memory tool enabled me to fix that. Last 2 things I want to show that we've added into Visual Studio 2015 that are just little productivity things is I've been setting breakpoints the whole time. And if you may have noticed that these little tool bar popped up, if I click this, we've had conditional breakpoints and trace points in the product for a while, but we've combined those into a single non-modal window, so I can still interact with my source code. I can combine conditions, and so if I want to set a conditional breakpoint, if the number's 4 or 5, I can do that. And I can also set a trace point that will print information to the watch window, and that's all available in this great non-modal UI. The last feature that I want to show that we're pretty proud of that was added in Update 1, I'm going to make a guess of 101. And the debugger is going to break, and it's going to tell me that there was a read access violation that occurred. But as part of the message, it actually tells me the expression in my code that's triggering the read access violation. So I can see it's guess result, arrow, server result, where down here I have guess result, arrow, server result, result. So I know that server result has not been initialized correctly, and trying to access server result is actually what's triggering the read access violation. So that was added in Update 1, and so we now, that works for function pointers, that works for any time you're going to trigger a read or write access violation. So that's what I want to talk about today. So just a quick review of what we talked about. So we talked about the integrated performance tools, we talked about the perf tips, the memory profiler, the CPU profiler, edit and continue, NatViz, the improved breakpoints UI, and the exception settings, along with telling you what triggers a read and write access violations.
Cool. So you showed us local debugging So I have a lot of VMs running in Azure with all my operating system that I need to test my app on. Will any of these features apply to the remote debugging as well?
Yeah, absolutely. They will all work when remote debugging.
Sweet. OK, thank you very much, Andrew.
Even
Let's give him a warm applause. All right, so we talked about benefiting from day one no-code changes. Then we showed you the productivity tools, both in the editor and in the debugger. And now I'm sure you're feeling the need to write a lot of code. But what kind of code are you going to write? C++ offers you a great range of ways you can write the code. It gives you this big shotgun, and you can shoot yourself in the foot. What we all aspire to is to write portable and modern C++. And I'm going to talk a bit about our efforts to help you in 2015 to do that. So we're making huge improvements to the compiler in 2015. This is a long list of standard compliance features that we added, both improved from 2013 and new in 2015. Some of the things are already work in progress. They're not done yet. One of the big things we added in update 1 is expression spine, and we're going to continue working on that, and we will eventually make it. C++ 14, we just added variable templates as well. And in C++ 17, we're making experimental implementations of some of the TSs being discussed in that context, like coroutines and modules. The promise that we want to make you is that we're going to actually continue improving the standard conformance in Visual Studio 2015. So features like extended const expert and SDMI for aggregates in C++ 14 will be coming in the next updates. So we will get to a point where we have a much larger conformance surface, and you can focus on writing modern C++ code. Now, as Herb says it, there is a drawer of knives in the C++ language, right? We all want to write modern C++ code, but all of the existing C++ constructs that sometimes make it harder to understand the memory safety, type safety, and everything, it kind of still there. So I want to talk about something new. How many of you were at CPPCon last year? Just a few, 2 or 3. So Bjarne Sturstrup said that inside C++, there's this simpler, safer language struggling to get out. And this was, I think, before CPPCon. At CPPCon, he actually announced the C++ core guidelines, which is a set of rules that if you follow, and I should click next, because you're going to see the highlight, you actually get statically type safe, no resource leaks, and catches most of the programming logic errors that are common in code today. And it runs fast. That is the promise of the C++ core guidelines. Now, this is a document that it's a work in progress. It's out there on GitHub. You can contribute as well. And it's being contributed by many people in the C++ community. It's, I think it was 80 pages long the last time I looked at it. It might be longer by now. So there's also a question, how can we actually write this modern C++ code? So there's code reviews that we can do. It's our aspiration of writing better code, but we need tooling as well. And that's where Visual Studio 2015 comes in, and it brings you those tools. We have static analysis tools. We call them core checkers. They will actually go through the code that you have today and find those bound checks that you should really be checking. You're basically doing pointer arithmetic, and you shouldn't. We're going to have rules that type checks, and just today, we're releasing an update to the core checkers that will have lifetime checks as well in it. This is an experimental thing. Definitely go out and try it and give us your feedback. There's still work that we need to do there to get it up to par to actually have confidence that it's good for your code base. That's the core checkers. Now, there's also a guideline support library, which will help you write better code. And I'll actually get into an example next. So don't read too deep into this code base. It's an extract of a much longer function with only the essential parts. As you can see, as a classical function, it takes a pointer and an int, which it's a hint that maybe that pointer points to an array, and count will be the size. There are operations being done there on the pointer, pointer arithmetic, line 3 and 4, and 10 to 12. There's some pointer diffing there between 6 and 8 and an uninitialized variable. So actually, if we start throwing static analysis with the core checkers on it, this is the errors you're going to get. Now, this is legal C++ code. No one tells you that you're not allowed to write code like this. It's only a choice whether you want to keep using it like this and you're confident about this being correct, or you want to fix it. It's up to you. So let's see. Line 4, don't use pointer arithmetic. P+1 will be pointer arithmetic in this case. The recommendation is use span. Really, what that tells is that a pointer should point to only one element. If it's int star, it needs to point to an int, not to a vector event. If you really want to point to a vector event, you don't have enough information to use the pointer. You have to have a pointer and a size, and span gives you that. Line 7 tells you that the variable n is uninitialized, and you should be initializing all variables. So the same is true for line 10 and line 12. So now let's see how this looks like by throwing GSL into the mix. So let's actually use span instead of a pointer and a size. So it's a drop-in replacement. Now you take a GSL span of int, and you can see in the call side, line 17, there's just it's very simple to change the call to the function f from a, comma 10 to use the curly braces. It's the uniform initializer. They will just create a span for you. The compiler will be able to tell. So it's not a huge change in code base. Line 4, line 10, and line 11 now, because you're using span, will actually be checked against the boundaries. So you know for sure that your code is safe. And if the checks are repetitive, some of those checks will be hoisted out by the optimizer eventually. So you're not paying a huge penalty in the checks, but you're also getting the security out of it. And then if you look at the line between 6 and 8, I think what the code does there is just trying to do a diff between the distance in the stack between int n and the array being allocated, getting passed in. So this is the drawer knife that Herb is talking about. Like if you know what you're doing, even if you're not doing something safe, just mark it as such. It's still legal code. And you can tell core checkers, hey, I know what I'm doing. I'm going to suppress the type 5 warning here because I don't need to initialize the variable. I only use it as a tag point to calculate the difference. And then the last thing for line 12, the point is the function use, it's still taking a pointer and a size. And you can continue using those. This is a gradual process of slowly moving towards a span, slowly moving towards a more safer construct and more modern usage of it. So you don't have to buy it all in. You can do it gradually as you go through it. So that is the portable and modern C++ part. That was a quick overview. I definitely recommend you following the links that I had on the slides. Now, modern C++ is a choice. Writing portable code is not always a choice. We have to consider bringing code from other platforms to Windows. We have to consider porting code from Windows to Linux. And we hear that more and more often. So the reason number 2 that I want to talk with you today to consider using Visual Studio 2015 is that we're providing Linux targeting. Just today, we're releasing a new extension out there on the Visual Studio Gallery that you can download. And you can start debugging, editing code on Linux. And I'll show you right now how that works. So I have the same code over here. It's a Linux project this time. See, it says here in the title. And I created it by going to New Project after I installed the extension. And under cross-platform, I have Linux with a bunch of templates. So I choose console application. And now all I need to do is hit F5. I already paired the Visual Studio instance with my Linux VM that is running here. And if I hit F5, this will actually build and run my app. It's going to take a bit to run the build. So the build runs remotely on the Linux machine. The debugger runs remotely, and we connect to the debugger. And I have build errors, which is not unexpected. Oh, I could not connect. Well, I'll definitely not be able to fix this on stage right now. So this is an incentive for you to go try it yourself on your VMs. The point that I was going to make really quick as we go through it is that this is the familiar experience you have in VS. Andrew was showing earlier NatVis on Windows. NatVis work with Linux when you debug on Linux. IntelliSense works, refactoring works. The features that you're familiar with Visual Studio will help you target both on Linux and on Windows. And I will switch to the slides. And I apologize for technical difficulties. So you can target desktop, Linux, server, and IoT. So we support x64, x86, and ARM architectures. So you can use it for Raspberry Pi and so on. The dependencies is very small. So you only need to install a SSH connection, an SSH server to connect to Linux, GDB server, and G++ for building, and that's all you need. So any distros that have those capabilities, should be most of all, you can debug from Visual Studio. And what I didn't show you in the UI, in Tools option, you have a way of adding as many boxes of Linux that you want to debug on as you can. So it could be Azure VMs, it could be local VMs, it could be machines on your network, and they will just work as long as SSH is open for them. So please go download the extension today on Visual Studio Gallery. There's a link over there, but you can search for Visual Studio, Visual C++ support for Linux. All right. So now moving to reason number 1, target one mobile platform from one IDE. That doesn't sound right, Ankit. Can you help me out?
Sorry, maybe I can just start here. Yeah, that definitely doesn't sound right. Target one mobile platform, one IDE.
No.
I
messed up the slides.
Yeah, I think so. So let's go ahead and fix that one. So it's actually target all mobile platforms from one IDE.
Yeah.
All right. So how many people actually knew here that you can target Android, iOS, Windows, and Linux from Visual Studio? Not many. So we're going to fix that today, hopefully. So what I'm going to go into is go into a demo right away because we're a little bit short on time. And I'm going to talk while I'm doing this. So really, you can actually target, with 2015, you can target Android, Windows, iOS from Visual Studio for all your C++ code. You'll get the same kind of experience that you have on Windows today for targeting these devices as well. You'll be able to debug your code with the same productivity experience, the same kind of state-of-the-art core editing features, and so on. So how do you actually get there? So if you open up Visual Studio 2015 and you go to File, New Project, and you look for this cross-platform section, this will actually get into all the templates that we have, which are for Android and iOS. What I have here on the screen right now is basically an example, which is called the More Teapot sample. This is a sample from the Android native development kit. And what it really is it's got a variety of Java and C++ code in it. So let's actually open up a Java source file, which is really located in this More Teapots project, and show you some of the features that we have. So notice this is my Java source file, and notice that I have all these squiggles here. Does anybody who actually didn't see me do that know why we're actually seeing a squiggle on this import API? Come on. So since none of
used,
it's
can I guess?
Right,
not
you
allowed?
can guess.
Okay,
Come
fine.
on, right? So I think the party here is that since none of us actually are, at least I'm not a Java expert, we actually have Java IntelliSense to help you out here. So if you hover over it, you can actually see that this API is not being used. So this particular package is not being used. So let's actually go ahead and use it. So I'm actually going to go and create a usage of this API. And as soon as I see that, I do that, you'll start seeing Java IntelliSense pop up. So actually, I can go here and say inside Android context, and I can say on create. That's the function I'm in. And as soon as I've done that, you'll see that the squiggle that was on the Android util log package goes away because that's really just the IntelliSense now operating on top of that. Other language features like go to definition and stuff like that, they automatically work as well. Now, this is really a C++ talk, so let's get back to C++. So what's really happening in this app, as I told you earlier, it's a Java and C++ app. The C++ portion is being built as a library, which is getting consumed in the Java portion. So the C++ library is really building as a part of this project right here. Let's look at the project properties for a section. So project properties will allow you to view some important characteristics about this project. For example, you can see here that I'm building a library. I'm targeting Android API level 19. I can actually also choose between different platform tool sets like Clang and GCC in this case. And you can all do that from Visual Studio. So let me actually bring up some C++ source now and do the same thing here to show you some of the language experience here. So Android main, which is in this particular library function, is really the entry point API for your C++ code. And I'm going to do the same thing here. I'm actually going to go ahead and add another log print message here, which is inside. So I'm going to, again, use the Android IntelliSense that we added. And I'm going to say inside Android main. So notice again, I can again leverage the same kind of language service experience that we have for C++ and Java as you're writing an Android app. Other things like go to definition, peak definition, they just work as well. So I can actually go here and say peak definition. You can see the definition that's coming from there. I can actually say go to definition. That will work as well. Like Marin showed you earlier, things like refactoring for Android work as well. So it's basically what we're talking about here is bringing the same experience that you enjoy today in Visual Studio for the Windows element experience for Android and iOS as well. So here actually I'm going to go and say instead of state, I'm going to say smile state. And again, the same refactoring menu will come up here that Marin demoed, and I can then go and apply it. So that's just showing you the code editing experience so far. Next, I want to be able to show you being able to build this app and then be able to debug it. So what I'm going to do here is that I'm actually going to hit F5. Not only in the Android experience that we offer in Visual Studio, we have a good solution for building and code editing and debugging, we also have our own Android emulator. Because when we started this project, the Android emulation story was not all that great. So since I already have the emulator running here in the background, all I'm going to do is hit F5. But before I do that, let me actually hit a couple of breakpoints here. So notice it's going to ask me to build this app. As this app is getting built, currently we support both the build systems in Android. Android has Gradle build system. It also has Ant build system. We support both these build systems here. Our experience is pretty nice. You can see the app was built successfully. And now we're just about to I placed my breakpoint incorrectly on the thing, but there we go. So you can see here that the breakpoint that I added to my C++ code here, that gets hit. I can do all the things that you can imagine in the Windows world that Andrew and Marin were showing. You can view a call stack, you can view breakpoints window, you can do conditional breakpoints, you can add things to watch, and of course, NatFizz also always works. So this is me showing you C++ debugging right now. But another thing that actually works here, since Android applications are somewhat Java and C++ as well, especially for games and so on, we also support Java debugging. So if you want to be able to debug your Java code, you can actually also do that here very easily by going in your Java sources again. So I'm going to bring up my Java source file here back in a second. And I'm going to hit a breakpoint here in my logging API. And again, I'm going to redeploy, and then I'm going to redeploy the app. So one more thing, the mistake that I did right now is that the one more thing I need to do right now is actually go change the debugger type here. So currently, we don't allow you to be able to debug Java and C++ simultaneously. You have to choose at build time, at design time, which portion of the code you're debugging. So right now, we were debugging C++ code, but now I'm going to actually go and change this to Java and click Apply. This will now allow me to debug my Java code instead of my C++ code. So let's actually go ahead and try that. So again, I'm going to hit F5, which is basically going to deploy my app. And now I've set the breakpoint in my Java piece of source code. And there you go. Now I'm actually breaking to my Java source code. So if you look here again in the locals window, you can go in here. You'll see this is an Android app application. You can see if you want to go into the array list in here, this is the Java util array list and so on. So what we talked about here is just kind of like showing you guys about how not only you can use your Visual Studio for developing for Windows, but also for Android, and the experience that we have for Java and C++ there, whether it's code editing, debugging, or emulation of your app. So that's the first demo that I had. Now, I know that we're a little bit over time, so we can either skip slides, and you guys can see a really cool iOS demo. So how many people here want to see a really cool iOS demo? Because we're a little bit out of time. So stick around and bear with me there, and I'm actually going to go to a different machine now. So as I mentioned to you guys, that not only can we do Windows and Android, we can actually do a little bit more than that. We can also actually bring in existing iOS apps from Xcode, import them into Visual Studio, then be able to build them. Now, if I ever want to go back to Xcode again, I can still do that by opening my Xcode project from Visual Studio on my Mac, make a bunch of changes there, and then bring it back again. So I'm going to start with importing an iOS application here. So what you can do right now is you can use this functionality called File New Import from Xcode. So here, this wizard will allow you to bring in your Xcode project. All you have to do is copy over the project that you have. In this case, I already have one on my drive. So I'm actually just going to use that one. So I'll point to the the Xcode project here. That's right here. This wizard is designed to help you bring in your Xcode project and take some of the concept that Xcode has and bring it into Visual Studio. So the first screen here is just telling you that, okay, when you're going to move into Visual Studio, I'm going to create these 3 projects. These 3 projects are going to have your Objective-C code, which is right here. We're going to have your storyboard and other kind of stuff. When I hit next here, this is telling you that your application is also referencing the C++ library. And we're going to import that one for you as well. As you go onto the wizard, you can also make this work for frameworks and all that. In the interest of time, I'm just actually going to click import. And hopefully that will work. So there you go. That's your Xcode project now opening in Visual Studio. So not only can I actually import this project, I can actually also go ahead and build it. So you guys can choose an emulator here. I'm going to go with the 5S simulator that iOS provides and build. So as I'm actually building this, let me explain to you how this works. So currently, your project and all your sources and libraries is on Visual Studio. But what happens is that we actually have a Mac paired here, which is right here, which I'm going to go into soon, which is allowing us to be able to build this application. So what's happening is that we take our sources, your entire sources here, your storyboard, your assets, copy them over to the Mac, build it on the Mac, deploy it on the simulator or the device that's being connected to the Mac. So as you can see here, right now so far, I'm able to bring this here and be able to build it successfully. So the build actually succeeded. So for the next part, I'm actually going to move here, and this is going to be a little bit troublesome. Marion, can you put me on 6?
I can.
So I'm going to move here.
It's coming up.
And I'm going to show you the app here. So this is the actual app that exists. Oops. So that's the app here.
6, you said?
Yep.
Okay, let's try again.
Go back to 6. Let's try this again. Just one more time, otherwise. This is 6.
Yeah, it says 6.
All right, so I think we're having some issues here. Can you go back to 5? I'll just do it from here. So another feature that I was going to show you, the app running and so on, but the other feature that we have here for iOS is also, since we actually don't have the entire experience, for example, if you're designing a UI, which you can't see right now, but if you're designing a UI, you might actually want to go back to Xcode and do some fixes there. Or you might want to still be able to use some iOS Xcode instruments. And for that kind of a scenario, what you can really do is you can right-click on your project, and you can basically take this Visual Studio project and hit this functionality called Open in Xcode. And what this would do is this will actually open up your project in Xcode, allow you to make a bunch of changes there. And once you're done making changes in your Xcode experience and Xcode IDE, you can actually bring them back to Visual Studio by saying remote machine, incremental pull from remote. And that will just kind of like bring in all your changes that you made to the Mac. So it's really a really nice story that we have in Visual Studio about your Windows, Android, and iOS development experience. And you can start using that today with 2015. I'll give it back to you, Marion.
Thank you. That's pretty nice. Thank you, Ankit.
Thank you.
OK, so just to show that it's not vaporware Linux debugging, sorry, guys. I had some Wi-Fi connection, so you see it working here. I'll go back to the slides. So we also launched Clang support targeting Windows. So we combine the front-end Clang with the Microsoft code generation tool so that you get the best of both worlds. So bringing code coming from other platforms into Windows that potentially take advantage of language features that are not available in our compiler. It's possible today, and I encourage you to use it as well. So that's our list today of 6 reasons, but this is not all. There is one more announcement that I want to make. So we know that we had some interesting demos, and maybe you feel compelled to upgrade to 2015, but we know that it's hard to upgrade to 2015. So it takes time. It's a cost-benefit analysis. Depending on the larger the code base is, maybe there are challenges to upgrade. So we want to make it easier for you. And today, we're announcing 2 things. During this build talk, this build conference, you're going to hear a lot about VS Air Code 15, which is the new version. It's already in preview today, and you may say, well, cost-benefit analysis, maybe I'm going to wait for that version to upgrade, and maybe I'm going to skip Visual Studio 2015. Well, I'm not going to give you that reason. You're not allowed to have that reason, because the promise we're making is that that compiler and that library that ships in VS Air Code 15 will be highly compatible with the version that ships in VS 2015. We're going to continue evolving the compiler and the libraries and placing them in both trains. When we run out of Visual Studio updates in 2015, we will continue evolving the same compiler in VS Air Code 15 when that happens, and there are going to be releases there. So you basically have zero friction adoption now from 2015 to VS 15, which is so confusing to call them like that. So the second promise is that we will try to help you upgrade. And you better write this down, because the availability will be limited. We are volunteering the whole C++ team back in Redmond to help migrate and handhold on one-on-one customer calls your code base. So you sign up here. This is how it works. You enter your email address. You get a survey where you get more questions about your code base. And then we're going to call you back, and we're going to set up a Skype call where we walk through every issues that you run into upgrading. Let's say breaking changes in the compiler, breaking changes in the libraries, and so on. We're going to collect all this information up and make it available for people that didn't make it into this program and didn't have the capacity. So you'll still have the information to upgrade. And we'll continue evolving this documentation. So please sign up today. And we have a list of recommended sessions. Together with Ankit and Andrew today, I want to thank you for coming today. Enjoy the rest of the build, and go build great things. Thank you.